So hello judges, we are Team Bharat. I am Anirudh Pratap Singh Yadav. Alongside me is my team leader Mohammad Rehan and Prayash Raj Mishra. So welcome to Swift Logic Commerce Ops. This is our e-commerce agent. So basically, let me explain you the problem first. So real e-commerce doesn't fail from one bad choice, or it dies from a cascade of systematic failures. Imagine trying to run multiple distinct commerce businesses simultaneously. So imagine you are maybe vendor A faces certain stock shortages, vendor B is bleeding its budget on ineffective marketing, vendor C is drowning in bad customer reviews, and maybe vendor D has completely mismanaged their cash flow on how cash flows. So we are just making a commerce agent. So optimizing for just one of these is not viable. So we have created for all of the four situations. So we built an autonomous AI CEO, the agent that simultaneously balances service quality, inventory, and profitability in the under crisis recovery. And this is a multi-agent marketing condition. So our solution directly targets three UN Sustainable Development Goals, as I can show you. So as you can see, SDG 8, SDG 9, SDG 12. So SDG 8 by preventing small business collapses and securing economic growth. SDG 9 through building resilient and automated infrastructure. SDG 12 by cutting down wasted inventory. And so before I start, let me explain the full pipeline schematic. As you can see, it flows from market state to operator core, decision engine, where it is basically heuristic. So we have just made a decision engine without taking help of any LLM, because LLM might be like it was a criteria, so not use LLM. So our world is driven by dynamic JSON configs, letting us instantly hot swap the environment from a fashion retailer to a SaaS startup engine, right, without changing code. So our open ENV world engine simulates the realistic physics, Poisson distributed demand data and market shocks, which reactive our CEO inference layer reads the state and executes structured actions over strict HTTP endpoints. So let me explain the model training and why we selected the QWEN 2.5 model for the as a baseline, which act as a parameter, and then we do reinforcement learning, so it learns from the data itself, and we have then use Unsloth for the faster mode and the GRPO for taking more on the learning rate. So these are the artifacts I'm going to show, but first before that let's try a test and model. So let me just show the launch autonomous shift once, and you will be able to see all the graphs here. Yeah, so these are visible, right? And same with the, let me do remain refresh retail spread. So as you can see, 16 in stock, 0 in stock, 0 in stock, 0 in stock. So it's visible, right? And these are the ones, and these are the graphs. These are the learning rates from which are visible quite freely. And you can also see the my artifacts. These are all the artifacts and the score which I got in my dataset. This is the scale proof. Here you can see all the things we have done, and this is the storytelling, like, which can be done in any way, right? So this can be a scalable future product as well, and I hope to see in the result section, right? Thank you.